Weird sciencey facts that hurt my mind. And boggle it. Beam me up, Scotty, because teleportation is real. Kind of. Something mankind has long dreamt about doing is developing the technology to transport people and stuff anywhere instantly. After all, that European vacation would be a lot more feasible if it didn't have that 24-hour plane ride. But unfortunately, breaking solid matter down into particle beams and beaming it around the world or the universe has some obvious obstacles. But quantum mechanics, on the other hand, just doesn't follow any rules, apparently. And even while quantum particles can't physically teleport the way that we envision teleportation to be, they have a trick to teleport information that is even crazier than if teleportation was real. And before you be like, oh, I'm watching teleported information on my phone right now, yes and no. It's not the same, and I promise you're gonna want to hear it, because it's fucking crazy. So your phone receives and sends information via waves. And while it's not physically linked to the sources that it's getting and sending its information to, waves are still a physical connection. It sends a signal that has physical properties that is received by another thing that processes that information. And that signal has limited range and limited speed and can be blocked, which is why you can never get a phone call out when you start hearing banjos. But quantum particles, on the other hand, are like psychic twins from a flippin' horror movie. This phenomenon is called quantum entanglement. Now, the smartest people in the world barely understand this. Albert Einstein called it spooky action at a distance, if that gives you kind of a grasp of the smartest people in the world's grasp on this phenomena. And I am not one of the smartest people in the world, so bear with me as I butcher my way through explaining this. Quantum entanglement is where subatomic particles like photons and electrons have this like psychic link with other subatomic particles, like they're the frickin' shining twins or something. And when you move one of these particles, like change its position or make it spin a different way, the other one moves too. But here's the thing. They don't need to be close to each other like at all. Like the furthest distance that they've recorded doing this so far, they used a satellite and did it at a distance of almost 900 miles away. And the reactions happen at nearly the speed of light. They've even done this experiment with like really tiny diamonds, apparently. Just try to wrap your head around that for a minute. They just move this tiny particle and it can play a game of Magic Simon Says with another one 1,000 miles away. And now that's all super cool, right? But that's not teleportation. And you're right, sort of, but it's teleporting information. You can put an input into one particle on one side and receive that information, see what that input was on the other side. And this can be done over an indefinite amount of distance. It can't be blocked as far as we're aware of. You don't even have to know where the signal's coming from, and you can't trace it because there's no link between them, at least that we can find, perceive, or measure. So they call this quantum teleportation because you can literally use it to teleport information. And they're studying this for quantum computing because it can transfer information at nearly the speed of light, which, you know, really cuts down on buffer times. It's also apparently going to help with super dense quantum computing codes. You know how regular computing codes are binary, they're ones and zeros, so you have to have a ton of yes-no questions to like process any information. Quantum particles, on the other hand, can exist in multiple places at the same time. How? Again, we don't know. And that means that you can use their positions to make code way more complex, and this is all part of that too. How? I don't know. Even the scientists working on it don't really know how. Just to put into perspective how flippin' crazy this is, years ago when I was first reading about quantum computing, because I was like, oh yeah, I am sure I could understand the basics of this, because I am way too overconfident in my own cognitive abilities, apparently. I was reading a quote from one of the physicists working on a quantum computing project, and he's like, I see this phenomenon with my own eyes of physical particles being in two places at once every day. I'm using that data to build functioning machines, and I still don't believe in it. I believe it defies the laws of physics, and it isn't real, even though I know it's real because I'm working with it every day. He says he has to check his understandings of reality at the door because his understandings of the mechanics of the universe cannot coexist with the actual physical work he's doing and seeing with his own eyes and his own hands every day. And the fact that some of the smartest people who have ever lived in the history of the world are building machines and doing experiments that defy the very fabric of the laws of physics as we know them, and even they have no idea how or why that's happening and how they can do that, well, that is pretty mind-boggling.